check that the issuer on the chain on the certificate you're looking at matches the subject of its parent. If there are these authority and subject key IDs in either of them, then they must match. You check that the dates are valid, and you check that the key usage is correct. So this isn't a code signing thing that I'm doing. This is an SSL chain that I'm verifying. I don't want to see your code signing certain here, thanks. And then you also have to look and make sure that there's no critical properties, something flagged in that certificate that you don't understand what it means. Because maybe that means, hey, this certificate isn't valid for you. And that stops us from missing important extensions that we need to be able to grok.
That's a great question, and it would be a really easy bunch of SQL queries to do. So either if we're not going to finish this talk early probably, but if we finish it early, we could have done the SQL queries for you, showing you live on the screen. Failing that, we can come and do it we can go and do it in the breakout session, or once the data set is public, it'll be pretty easy for you guys to just go and look at those properties yourself.
He's pretty good at quickly turning those into pictures too. So.
So there's a big partition out there between valid and invalid certs, and there are a few that were on the grey line in between that we had to struggle with as we learned a bit more about this. One example that we discovered is that sometimes a certificate, whether a certificate is valid in Firefox or not, depends on what other sites you've been to beforehand. That was non-intuitive, but what happens is whenever Firefox sees a subordinate or intermediate CA that it considers valid, it caches it. And so, and that's sort of, part of the system. Those things are valid if they're signed by a root you trust, so you cache them. And so sometimes a chain will depend on an intermediate or subordinate CA that it doesn't contain. And so if you've already cached that middle cert when you go to the site, it's valid. If you haven't already cached it, it isn't. So this is crazy stuff like this. But aside from that thin gray line in the middle, you've got a world of black and white. And in the black world, the invalid world, there's all sorts of crazy stuff going on. There are lots of certs out on the internet that claim to be Microsoft, claim to be Google, claim to be Star. There are things that look like telcos in Southeast Asian countries. Maybe they're man in the middling the users. More likely what it is that they have a WAP gateway, which is the old mobile internet thing, and those require you to
impersonate.
Yeah, to impersonate the server because they didn't have proper infrastructure for TLS in there. So there's all this crazy stuff out there. But most of this talk, unless otherwise noted, is about the white certs. The certs that are valid, that check out when you go to them with a modern Firefox or IE, and they give you the little lock icon. And what kind of questions do we want to ask about them? How many are there? Who are they? What do they sign? Is anyone impersonating anyone?
So the number of trusted CAs is kind of a tricky question. So if we're going to figure out who browsers trust, we want to know what the trust roots are. And if you just fire up those browsers, maybe you look in your Mozilla trust root, you see 124 trust roots representing around 60 organizations. That's some indication. When you fire up Windows 7, open up IE, you see 19 trust roots, and you think, oh wow, those guys have really tightened that down.
Except what Microsoft actually does is when you're going to a website and your browser doesn't instantly check out, it doesn't check out the root isn't in your list of 19, IE actually goes and pings Microsoft and says, so should I really trust this root CA? And Microsoft has a list of about 300 of these certs that they might give you. And they come from 100 or so controlling organizations. So one really nasty thing about this user interface is if you care about who you trust and you go and look at the IE list, you don't get the real list. You get this little sanitized version of it. And so we had to go and get the real sorted complete IE list and use that as the...
Although, to be fair, they do document this whole process and actually provide a lot of insight as to what they'll do if say breaks like the break that just happened last year happens to SHA-1. They have a whole plan for what they're going to do with eliminating certificate authorities, say, that don't bother to randomize their serial number. Right? So they'll invalidate them long before they'll invalidate people that properly invalidate them.
I didn't mean to call Microsoft sorted. So how many of these things are there? I mean, obviously you've got this set of roots that Microsoft and Firefox trust explicitly. But then, of course, because so many of these are delegated and have the power to create new CA certificates, there's actually a larger set that we found. There are 1,482 that were valid for either Windows and Firefox. Now remember, these are often multiple certs controlled by one organization, so the large number in and of itself isn't necessarily damning. In fact, it's good practice to keep your most powerful keys off the internet and then have one that has a shorter expiry date, perhaps on a server somewhere where you're actually signing things. But if you say how many issuer strings, which is the kind of magic thing that you look up the cert by, are there are 1,100. And if you look inside the issuer, there's a field that says organization. And if you sometimes if you count those plus some fallback options, you get about 650 organizations that have the power to sign a cert that your browser will trust to be google.com. Now, some of those organizations might be owned by some of the others, and the jurisdictions that they work in might overlap. It's complicated, but the general principle that you should remember underlying all of this is that if a CA cert can sign one domain, it can sign every domain on the internet. So each CA has many certificates, but the combination of the issuer and the authority key ID, which is actually the subject key ID in the issuer's cert, that's a unique combination. So you can look at the top CAs that we found in use on the internet to sign. These are valid signatures. We found one GoDaddy cert. This is its fingerprint here. It signed 300,000 different CA or certificates. The next biggest one was Equifax. They signed 244,000. When you get down to Thought, you find one that doesn't have a subject key ID in it, which means that when you're looking it up, you have to look for every certificate in your trust root that has that issuer name, and that can take a lot of time because you need to try, if there's multiple keys in there, you have to do expensive PKI or public key operations for each of those to validate that it's true, and if one isn't correct, maybe the next one is, so you have to keep trying. And then 85,000 plus from user trusts for certs, all with the same SCID, which is kind of a strange thing. It's possible that when you're doing certificate revocation, you might want to have kind of different domains. It's a really a weird kind of world to see which ones have unique keys and which ones have unique SCIDs. So one of the things about these validity assumptions here is that we're doing this with OpenSSL and a version of OpenSSL that isn't too fussy about MD5. It's a little bit older, and ones that are valid based on the Firefox trust roots or on all the IE ones that you get, and you can just download those, and we have a contributor who did that. Oh, SCID. SCID is the subject key identifier. It's an X509v3 option. They showed up in like 1998. I'll talk about them a little more later, but it's one of the things that if it's present, they have to match. If it isn't present, they don't have to match, and it should be the keys identifier. In fact, there's a suggestion that maybe it's the SHA-1 hash of the key, but it doesn't have to be. Yeah?
How do you know that you know all of the Microsoft ones? Maybe they have a few secret ones that you said.
Yeah, that's a great question, actually. So, yeah, that's a really great question. The question was, how do you know that we have all the Microsoft ones? Maybe they have secret ones. So, there's a lot of stuff going on here where certificate, like trust roots, sign subordinates. And those subordinates have the same powers basically as the root, right? They can sign anything they want. They can sign other subordinates. You can see how sometimes trust roots will actually say when you ask them, oh, could you tell us all of your subordinate CAs you've signed? Oh, that's private information. That sort of...
So maybe a different interpretation of what you might have meant to ask. What we did is one of actually an ISEC intern got a version of XP, installed all the service packs, and this was before Windows had completely rolled out its magic update to the cert, and so you actually got all the certs, or a very large list of certs. We can't be sure that we got all of them. We got a very large list of certs that Microsoft would push as updates to Windows XP, but we can't be sure we've got that entire set. And it's almost certain that there are some certs in private domains that we can't see, and also that Microsoft could indeed, if they got a court order and decided it was valid, which is a separate question, they could silently add another cert to their set of trust roots, and we might never know.
You know, actually, any of these trust roots can do this, though. That was my point, right? You don't have to worry about Microsoft. You can worry about, you know, this funny company in the UAE that has one, right? They can do the same thing, and they don't need to add anything to your trust root. And it's even kind of better because you don't see it in the trust root there. If Microsoft added a root cert, as soon as someone started using it, it'd become visible in your browser, and you'd be able to see that's the chain, right? These intermediate ones are a little bit sneakier. I think we better not take any more questions right now because we've got a lot of material to cover and not a lot of time.
Yep.
Just pop this for 1 second. This is an example of the top 14 certs that are actually used to sign leaves on the internet. And you can see that a lot of them are signed by the first two, and then it kind of trickles off, and then that big gray area there is the other. And you know, it gets kind of messy at the end.
So a different way of breaking that down, this was literally which certs were sort of immediately signing things. This is counting by root CAs. So not just what is signed directly by the root CA, but what is signed by the entire tree of things following it. And the 340 or so that are 343 that exist between Firefox and Windows. And so you see this extremely skewed distribution. In fact, you can't really see what's going on in this graph, so we made a log version of it and cheated a little bit. Actually, that's 0, not 1, but you can't have 0 on a log scale. So what you can see here is that about half of these root CAs aren't signing anything.
That might be because they're code signing certs that aren't used for signing SSL leaf nodes, and so when you do when you look at the SSLiverse, that's not what you see. But some of them are definitely SSL signing certificates.
Yeah, so some of these, and some of them might be new certs that are about to be deployed, but generally speaking, half of the certs we trust don't sign anything, and then there's another small group that sign 1, 2, 3, 4, up to 10, and then gradually you start to get certs that are of significance. So we don't want to provide specific interpretation for this graph yet, but it is quite interesting that it has this shape. We just actually talked about some of these. Yeah,
I'll blow through this quick, but there's this good case for a leaf to be unused, which is that when you have a more secure certificate, you need to push it out there. So I've got this new trust root. It's signed with a bigger key than the old one. It's got a nice late expiration date. I'm going to put it out there. I'm not going to sign anything with it until it's been widely adopted by all the different browser vendors. That's totally a legitimate case, and it actually improves the overall security of the system. So you know, you can't just say, oh, this isn't used, it's bad. Also, you might need a backup route, perhaps. Where it gets a little less legitimate is when you're thinking about subordinate CAs. I'm not sure why these would be unused. It seems like if you've got subordinate CAs, you know, those are pretty easy to get reissued, as evidenced by the hundreds of them that have been issued. It seems like that, you know, backup planning, revocation should be an easier story for those. So if anyone has any good arguments for that, I'd love to hear it in questions.
So do you want to?
Yeah, sure. So many valid CA certs share keys. So this is a funny thing. You've got this cert. It gives some authority. Maybe it's a CA cert. It's good for a period of time, and it's got some power, like it can be used for signing SSL certificates. And you know, you've got another one right beside it, and oh, that's funny. They have the same key, which means if you break certificate A, you broke certificate B, right? You can impersonate one with the other. So fortunately, we didn't see any valid CA keys that were used in non-CA keys, because that would be terrifying. It would imply that, you know, some little edge sitting on the on a web server somewhere was sitting with a real CA cert, and all you'd have to do is pop that thing, and you'd be in a good spot to do some harm. We identified 80 distinct keys that were used in multiple CA certs. And the most widely reused one was this VeriSign key from 2006. It's a strong 2048-bit key. The certs all share a subject, and they lack subject or authority IDs. 4 of them, there's only 4 of these keys all expire simultaneously in 2021, but one of them doesn't expire until 2036. So when you look at that, you think like, what is going on here? Why is it okay for these first ones to last only till 2021, but that last one till 2036? And you see a lot of interesting behavior like that. So Another place we looked at this was, here's just another example of this phenomenon. So these keys were shared between an organization. So we see certificate 1 and certificate 2. Certificate 2 is a Komodo cert